I've heard several times during the last couple of days coastal development, and I got really excited, but no one's actually, I guess, talked too much about it. But for me, this is an area that I get really quite excited about, and some work that I'm trying to, I guess, forge and bring together on very little money, but getting some exciting results. And I'm hoping, I guess, the thesis, the challenge I'm put forward from this talk, and certainly this conference, with these new funding horizons, is some more work in this coastal zone, this idea of green engineering. So the coastal seascape, we've got vegetation, we have these wonderful wetlands, we have salt marsh, we have mangroves, and these are important aquatic vegetation that sequesters carbon. They're also providing, I guess, a good basal source supporting higher trophic level production. So we've got various crab species and also various fish, which in some cases, the mangrove jack in this case here has a life cycle that spans across these coastal wetland areas and then to offshore fisheries, coral reefs. So a species like this has this important connectivity across the landscape. So when we're talking about coral reef restoration, we should also forget about some of these more land or nearshore habitats and provide that connectivity. However, we are modifying the coastline. We are changing entirely, in some cases, the seascape. And I actually find that quite impressive, that photo. I think, it's a major engineering achievement. But it changes entirely, if you think about it in terms of the seascape of the previous slide. So it poses questions around, how do fish, prawns and crabs and actually find habitat and food in these sorts of environments. We're also modifying the coastline to allow us to respond and adapt to climate change, or global warming, as Frank talked about earlier today. So we're building seawalls to allow us a bit of time, I guess, to adjust to sea level rise. Increasing storm and cyclone activity, it modifies our foreshore areas, and we have to respond to that by building more and more of these seawalls. Now that then also poses questions around changing entirely the hydrodynamics of coastal areas, but that's an entirely another talk which we won't get to today. So if you think about it as an ecologist, we have those wonderful intertidal zones, we've got the mangroves and the seagrass and the bare areas. They're important habitats in their own right for fish and crabs and lots of other things. But we are modifying the coastline, so we're actually truncating that intertidal zone. We've lost all those important habitat areas that are providing nursery areas, feeding areas for the range of species that we're talking about in the coastal zone. So we've truncated that intertidal zone entirely. So coastal development and in the marine space and in the GBR space sort of I started to think about, well, how much actual development are we talking about? How much coastal development, how much land use change have we experienced in the GBR space? So the wonderful Google Earth, quite a few late nights, a few bottles of red wine, sitting there on Google Earth, and allows you to put dots on each of these structures. So I actually did that. I looked at all the pontoons, all the rock walls, all the marinas, all the pylons, all the boat ramps, all the bridges, and actually put a dot and did some measurements around each of those coastal infrastructure to get an idea of the distribution and the number of these types of engineering structures. And what you can do then is for each estuary look at how much of the estuary has been modified. And surprisingly, although there's estuaries that have been entirely modified, to me is the actual distribution of some of these different engineering things. So you've got mangrove habitat interspersed with concrete walls interspersed with boat ramps and bridge pylons. So there was a big mix of these types of engineering structures. And to me, that sort of then reflects on the planning decisions. You think about a property development, they're thinking about within that footprint, not necessarily thinking about the entire seascape context. If we were able to pick up each of those engineering structures, put them end to end, it would actually spread about 10% of the coastline of the GBR, 10%. Is that a lot? 10%? I don't know. It seems like a lot. But I guess this is an important point that it's a benchmark, and so we can certainly come back with the beauty of Google Earth and remap these sorts of things to see how it's progressing. So 10% of the coastline has been modified. Also, the beauty of Google Earth, it allows you to change the year of the image that you're looking at. So I'm going to pick on Gladstone, where we've had some major port development happen in the last 5 or so years. So this image is 2011, and this is before we had a major surge of port development. And if you look closely at that yellow box, 2013, we had a 78% increase in the amount of seawalls built in 2 years. We had about 7 linear kilometres of seawall that was built to provide infrastructure for those port developments. So in some cases, when the timing's right, coastal development can move ahead quite rapidly. So if you start looking at restoration ecology, some of the literature around that, you'll quickly find the work done by Holtz, where he's looked at in terrestrial senses, not necessarily in marine sense, but this idea of systems changing in response to degradation or land use change. Going from pristine habitat through sort of a hybrid state and then eventually to a novel state. And in his work, if you have a look at it, he talks about then if you can re-engineer back through those states. He argues that you wouldn't necessarily get back to a pristine state, but maybe some sort of hybrid or novel state, and that's kind of the best we can do. So if we apply that thinking now to our seawalls, the idea is that a seawall would mimic an intertidal rocky shore area. Now, very, very different habitats, but the idea of the seawall, and certainly some of the expectations around the ecology of seawalls, is that we're going to have a habitat that's very similar to a rocky shore. And from work that's been done, there's a handful of studies done around the world, the answer is really the seawalls don't provide a very good habitat for some of the critters and growth that you might see in a rocky shore intertidal area. And there's reasons for that. You've got different aspects, different areas, temperature changes, the fact that there's no water being retained in some of these seawalls. So very, very different ecology. So this, about sort of 12 years ago, led to this idea of green engineering. So can we actually tweak the engineering design a little bit to provide nature with a bit more of an opportunity to recolonise? So green engineering. So we're not talking about allowing people to remove mangroves, but if we're going to remove mangroves, that we can do it in some sort of balanced way. So there's been some really interesting designs and research. It hasn't been enough, but how we can tweak some of these engineering designs. So some work in Sydney where we've got a sandstone wall, they've removed rocks as part of the design. Doesn't compromise the integrity of the wall, but provides habitat niches for crabs and other things to colonise. Some work in Rotterdam. This is a pretty interesting idea of using rope and attaching that to a featureless, smooth pylon to provide the habitat complexity and the substrate for things to start to grow. And that work was a simple idea. It was a very inexpensive idea, and they were able to show that oysters and snails and other things were starting to attach and colonise around those structures. So a very, very simple idea. It's green engineering. And some work done in Queensland fisheries is around attaching different structures to sort of pontoons and jetties and that sort of thing to provide, again, sort of more habitat complexity. So fast forward a couple more years, so a bit more recently, the last sort of 3 to 5 years, we've now advanced our thinking if we can attach additional structures to seawalls to provide increased habitat complexity, so more habitat features. And some really interesting work done by some colleagues in Singapore. They've used these tiles and looked at different rugosities, different complexities within the tiles to promote different increased habitat opportunities for things to grow. And you can chase the paper up, it's really quite interesting. Basically, the more complexity on the tiles, the more species they found living and attached to the tiles. Some work done with some colleagues in Sydney, this idea of attaching flower pots to a seawall. And the idea there is we're trying to recreate maybe still a hybrid type environment, but a water retaining feature on a seawall. And this is kind of the first study that was done with using this idea, and the results were remarkable in terms of the actual animals and plants and other things that were attached and living inside those little microcosms there, where the water was retained when the tide drops. So not to be outdone, we trialled that also in Townsville. So that's a temperate system. This is now a tropical system. The previous work was run for about sort of 10 weeks, sort of 12 weeks. But with the little bit of money I managed to pull together, a lot of my own blood, sweat and tears, down to Bunnings, I shouldn't product promote, but basically a water retaining feature, a flower pot attached to a seawall in Townsville. And over the 2 years that we were monitoring the data, monitoring the results there was clearly a separation in the actual colonisation of stuff, critters, bugs, all those sorts of things, to the outside, as opposed to what was inside. This clear separation across time. And in fact, the outside of those boxes, the few things we found there was kind of the same sorts of few things we were finding on the rock walls. So those flower pots in a tropical sense were actually, again, showing the same sort of results as the previous study, that it actually increasing some of the growth and critters that were colonising them. We also found, as part of that, and Susan talked about delivery of sediments to coastal areas, the flower pots that we had out were great at accumulating sediment. So we were able to measure that, and over the study we were accumulating sediment in those flower pots at about sort of 2 centimetres per year. So that hadn't actually been thought about in Sydney, because maybe they've got clear water, they've got that luxury of clear water environment. But in turbid tropical situations, it seems that there needs to be a maintenance phase built into this sort of technology. Otherwise, we might be negating the advantages that these flower pots are providing on seawalls. We've heard a lot about scale in the last couple of days. So to put my flower pots into context, very, very small within this marina, but it was an opportunity to prove that we could actually provide additional habitat features to a featureless seawall. And so that's the challenge that I'm putting forward now, is to try and now work about scaling up and using different designs to increase the opportunities for things to colonise on those seawalls. So this is from Singapore again, some more recent work, and really taking this idea of water retaining features and trialling different engineering feats to a featureless seawall, and they're getting some really interesting results coming from that. I'd actually propose also to think more broadly again at the seascape. We've got all this different habitat, all these different engineering features in the landscape, and so there's loads of opportunities, I think, to start thinking about these green engineering solutions and applying that to the different engineering structures we have across the seascape. A little project we're trying to get up with a local council just to the south of us. This is the Casabura Coast Council. A seawall that is degraded. It's about 1 kilometre long. They need to go back in and re-engineer the seawall. And the council is actually quite proactive and quite willing to spend that bit more money to include some of these green engineering type structures. So it's quite encouraging, and it's really encouraging actually to have a willing local government to try and embrace this type of technology. And I just thought I'd highlight that the member for Cairns on Monday night actually made the comment about sea level rise, and Cairns Council have just received a whole bunch of money to deal with sea level rise and coastal protection work. So I think we might take that challenge forward to him. Best practice, these are the only 2 documents I can find. This is a New South Wales document and a Queensland document around green engineering and trying to achieve better outcomes around coastal seawalls. There's just very little information, and certainly best practice not known. So some final points to consider, and I got the last slide of the last presentation on the last day, so fantastic. Coastal development is going on everywhere. It's not going to stop. It's going to continue happening. The coastal creep and spread of coastal areas, urban areas, is going to continue. And seawalls and various other engineering feats are going to have to be put in place. But the challenge is actually getting that balance right. And green engineering is certainly an opportunity to start to achieve that. We've got councils. There's 230 local governments in Australia that have sea frontage. We are girt by sea. And I think one council, one successful project, I would hope actually contributes to a snowball effect across other local governments. So we need to be supporting those local governments. And lastly, again, we need to get quite serious about this. This is a couple of $1,000. These little trials I had, getting some encouraging results. And so the trick and the challenge now is to scale this up. And I actually think we're well behind some of the other technologies overseas, certainly Singapore, in terms of knowledge in this space. So that's a real shame. I'm disappointed about that. And we're certainly well behind the development creep in terms of actually getting in front of development that's happening in coastal areas. So thanks.